Applying the basic integration rules requires a couple techniques. The first thing you might want to do is rewrite it. You would need to rewrite this. If you have like square roots in the denominator, you're going to want to make those numbers because, of course, when we integrate x to the n, it's x to the n plus 1 divided by n plus 1, and it's easier to see if you write it as a number. You might also need to multiply things out. If you have a square or cubic, you just multiply them out because we don't have the tools for integrating this just yet. You may need to divide out. If you have a polynomial in the numerator and the denominator, you may just need to do long division or whatever you need to get this into separate integrands. Again, we're not doing anything complicated yet. Or you may need to multiply through if you've got two functions multiplied by each other. Let's just do some examples and check them. Suppose I want to integrate 3x dx. Well, I know this is the same thing as 3 times the integral of x dx. I can factor that constant out. So this is 3, I raise the power by 1, divide by 2 plus c. Now how do I check? I just take the derivative with respect to x of 3x squared over 2 plus c. So this is 3 halves times 2x, and of course the plus c goes away, so this is 3x. This equals my integrand, so I'm good. I may need a sum here. Now you can separate these as x dx plus the integral of 3 dx. So this is x squared over 2 plus 3x plus c. Now first of all, you're going to see that you only need one constant. You don't need two. So when I check, I'm going to do the derivative with respect to x of x squared over 2 plus 3x plus c. So this is 2x over 2 plus 3 plus 0. So this is just x plus 3. This is my integrand, so I know I'm good. Same thing if I have trig functions. This is 2 times the integral of sine x dx. Now, sine and cosine tend to get people confused. The derivative of the sine is cosine. The derivative of cosine is minus sine. Let me take the derivative with respect to x, and you get in the habit of always taking the derivative to check you'll not lose this negative sign. So this is negative 2, the derivative of cosine is minus the sine, plus 0. So this is 2 sine of x. Now, we can do this for a really long, and I can write these out, but let's not. Let's just do one at a time. So this is 3x to the 5th over 5 minus 5 x cubed over 3 plus x squared over 2 plus 7x plus a constant. So if I want to check this, I just take the derivative with respect to x of 3/5 x to the 5th minus 5/3 x cubed plus x squared over 2 plus 7x plus c. So this becomes 3x to the 4th minus 5x cubed plus x plus 7, which is indeed my integrand. I'm good. Now, sometimes you're going to want to rewrite these. So let me write this as the integral of x to the negative 3 dx. So when I do this integration, it's x to the negative 3 plus 1 divided by negative 3 plus 1 plus c. And until you're comfortable doing these, please write out all these steps. So this is x to the negative 2 divided by negative 2 plus c. Or you can write this minus 1 over 2 x squared plus a constant. To check it, I'm going to take the derivative with respect to x of minus 1/2 x to the negative 2 plus c. So it's negative 1/2 times negative 2 x to the negative 3, which is indeed 1 over x cubed. When you have radicals, you're going to want to write this as the integral of x to the 1/2 dx, because this is now x to the 1/2 plus 1 divided by 1/2 plus 1 plus c. So this is x to the 3/2 divided by 3/2 plus c, and you do need to rewrite this as 2x to the 3/2 over 3 plus a constant. So when I check this, I take the derivative with respect to x of 2/3 x to the 3/2 plus c. So this is 2/3 times 3/2 x to the 1/2 plus 0, or just the square root of x.